We're continuing on with the 4 point, what notes are these? 4.6 notes. We're going to be looking at examples of 6 and 7. All right, so take a look at this. Now, when you first look at this, you might right away be thinking about a strategy, like dividing all of the terms by 5 would be a great one. Except there is something unusual about this one. Let's look at the directions for 6. Find a power series for f centered at x equals 3. So the previous example that we did was the Maclaurin series, and so it was centered at 0. And since it was centered at 0, it was totally sufficient for me to just have just x in there. But when you are talking about this centered at a different value, we need there to be the quantity x minus 3. Okay, so just a little planning on this. What we're looking for is whatever a ends up being. We would want a over 1 minus x minus 3, like that. That's actually what we're aiming for here in this problem. We need this x minus 3 because where it's centered, and it needs to be 1 minus x minus 3. So we are kind of trapped here. We've got to find a way to make the denominator look like this. Now, we were careful in giving you guys a problem here that would allow you to do that. So some of the things that you can do to this rational expression, you can multiply the numerator and the denominator by the same value. That's like what we do when we are getting a common denominator. We can divide the numerator and the denominator by the same value. That's like what we're doing when we reduce, and that's what we did in example 5. But neither of them here are going to give us that x minus 3, that 1 minus the quantity x minus 3. The other thing you can do is you can add and subtract the same value on the denominator. You technically could do that then on the numerator and or the denominator, but really it's the denominator here that's causing problems. So this is the strategy here that I'm gonna go for. I'm gonna add and subtract the exact same value. It's kind of gonna remind you a little of like when we complete the squares, how when we complete the square, how we would want to try to have, or whatever you add, you also subtract off to keep this balanced. So if I rewrite this, let's think real quickly. What would I want to take away from 4 so that I could get it down to 1? I'd want to take away 3. Well, the interesting thing here, so this would be like 4 minus x, but I can't just like subtract 3, right? If I want to subtract 3, I also need to add 3. Sorry. Somebody drove by. How dare they? My dogs are barking at them. Let's just take a look. Hopefully you guys can agree. This is equivalent to 5 over the quantity of 4 minus x. Now remember, I want to subtract 3 so I can get this down to a 1. But I also want it to have an x, the quantity x minus 3. Well, if we factor out a negative 1 from those two terms, I could do that. So I could have, if I just combine the 4 minus 3, I'd have 1. And then from the two remaining terms, if I factor out a negative, I'd have 1 minus the quantity of x minus 3. This is now in that form that I want for these geometric series. This is the form that I want. Okay, so again, we would have to be strategic about giving you guys problems where that strategy would work. But this is specifically because it's centered at 3 and not at 0. All right, so in this particular problem, a is 5 and r is x minus 3. All right, so I now want to write the power series for f of x. Now, g of x, if g of x is 1 over 1 minus x, remember this is 1 plus x squared plus x to the third plus dot 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 plus x to the power of n as my general term. So how are we going to manipulate this as a manipulation technique? Well, on the numerator, instead of a 1, we have a 5. So for f of x, I'm going to take g of x and multiply it by 5. And then my input, instead of just being x, is now the quantity x minus 3. So I will do 5 times 1, which is just 5, plus 5 times instead of x, I'll have x minus 3. Plus 5 times that input squared, and that instead of x is x minus 3, plus 5 times the input square or cubed, which is x minus 3, plus dot, 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 plus 5 times x minus 3 to the power of n, plus dot, dot, dot. And so I have my first 4 non-zero terms, 1, 2, 3, 4, and I have the general term, so I'm done with that one. We now want to see where this would converge to. Well, this is all about r. I want the absolute value of r to be less than 1. So, in order for this to happen, x minus 3 needs to be less than 1, and x minus 3 needs to be greater than negative 1. Now, there's a lot of different ways to think about this. The strategy you learned in Algebra 1 is you make it less than both a positive 1 and then greater than the negative 1. You take that symbol has to flip. A more graphical approach, if you prefer, is that you want this, if you think about where would I be if I want r to be 1 unit away, that would be in between 1 and negative 1. So x minus 3 has to be in between 1 and negative 1. I kind of like that way. It doesn't matter to me. And then add 3 to all the sides. And lo and behold, I get in between the inequality 2 and 4. Now remember, these endpoints will only be less than inequalities. We will never have the or equal to. And that is because this will only converge when r is less than 1. And it would diverge if r is greater than or equal to. So since this is geometric, we do not test the endpoints. There's no need. The endpoints will never be included. And that is the end of the video. Maybe if I can write endpoints. There we go, of 4.6.